What's happening? Happy Friday. Best day of the week. Fist bumps to everybody. Like our friends Daryl and Jim. Hey, happy to have you. I've got Twitch loaded over here so I can watch your comments. Today we're going to continue down the path of computer vision. So we're using computer vision to annotate pictures from a self-driving car. So right now we have a self-driving car, which is through a system called Carla. Whoa, I didn't spell it right, but that's okay. We'll let Google fix it for us. Driving, look at that. Let's see how bad we can spell today. So Carla will let us simulate road conditions, roads, cars, actors. Oh, it's really washed out, huh? Let me turn this down a little bit. Let's see if that helps. Nope. That's all right. It's just this big white screen. But it's really good. Carla is really fun. It's been a fun we've probably done it for at least a month now, these episodes. Last week what we did is we took images. I'll show you this one here. We took images from, let's see. Let's go to desktop. Let's go to Dude. Does Dude have it? Well, we had this image last week. So we took this image, we ran it through a Facebook library called Detectron, and Detectron labeled the person, labeled his backpack. It called his camera a parking meter. But that was fun. So we did that last week, and we did a little video too. So I did some dash. Here we go. So this was just me driving around my neighborhood and with a camera in the front of the car. And we used Detectron to do instant segmentation of these cars that drive past us. I just noticed that it got the street light as a kite, which is interesting. Cars over there, cars there, which are great. It'd be cool if it labeled the cars that are moving. You know, if it identified that it was a moving car rather than a static car, but that's still cool. And then up ahead here, traffic light. That's an important one too. So that's that. That was Detectron. Detectron was really cool. Now we're going to go with GluonCV. So Gluon is I think this is probably a better page here. Gluon will let us do all sorts of image CV tasks, so image detection or object detection, classification, things like that. Let's see if this... I don't want a video. Let's see here. Yeah, so image classification. How do we advance this? Can I just click it? There we go. Object detection, semantic detection, instant segmentation, pose estimation. All sorts of cool things we can do with it. So we're going to try that today with data from Carla. So the latest development on that is we've been using Carla, and we've been VNCing into a box that has Carla. I've got something else working now called No Machine, and No Machine will let me do this. So let me activate Carla. I'm actually in the EC2 machine right now. It's an NVIDIA box. It's got GPUs. It's a really solid machine for doing the work we want to do. But the good thing for us is if I do Python manual control.py, now we get full 60 frames a second. Whereas before, I think we were getting in the 40s, maybe the 20s sometimes. Sometimes we saw in the teens. This is a lot better. I have the image quality turned down just a little bit low for this Twitch stream, but we can adjust that too if we wanted to. But this gives us a way better way to work on it. I can work on this machine like I'm just sitting at my own desktop working on it, which is really nice. So we're going to take that. We're going to take those images that come out of that. We're going to do object detection with MXNet. So that's the task today. So what I'm going to do is I've already started one. I've got a library called main. And main is just based off manual control. So I just ran manual control. I started a new file that takes out a lot of the heavy stuff. So manual control is like 500 and something lines. Oh, it's more than that, isn't it? So it's in the 860 lines. And I broke it down. I broke it down into a main file and a HUD file and keyboard controls just to make it a little bit easier to work with. But I'll show you main. Also, instead of giving us a random car, main will just give us a world full of Teslas, which is fun to me. So we start off with a Tesla. Same world. Fewer vehicles. I have 16 in here, so there's one sitting there. All right. Almost collided with it. So that's that. So we want to take images from this, and we want to annotate it. We want to be able to have... Oh, Joel works early for once. Well, yeah, finally for you, it's a little bit earlier, right? It's at least, what is it, 3 hours earlier, so 3 o'clock there. That's great. Welcome, Joel work. Joel works in the UK. So unfortunately, it's on Fridays. The last thing he probably wants to do is sit here. 16:05. All right, 4:05. Last thing he wants to do on Fridays is sit here and watch, our Friday afternoons anyway, watch this kind of stuff. So I'm glad it worked out for you, Joel work. I've got another meeting today that conflicted with this, so that I have to be at. So we're going to do this a little early, which I'm fine with too. Let's see. Oh yeah, look, Jawwork, I am in your time zone here in this box, which is good. So now I can keep up with your world and my world. Okay, so what we want to do is, I've looked through here and I know the place I want to edit. I want to come to, let's see, what is it called? Screen recording. One thing I did, so with No Machine, I've got my keyboard mappings a little bit messed up. So Control F will normally do a find. Windows F doesn't do it. Oh, Windows F does do it. Okay, I think I got that fixed in. I rebooted right before the stream started. I was kind of struggling with that before it started. So we want self.recording enabled. I set that to true. And let's see. Right here, if self-recording. So right now what's happening is it's saving these images every frame it saves to disk. We're going to stop that. We don't really want to do that just yet. We want to look at the images and annotate them. So let's do this. We're going to say process image. We're going to go make a process image method. And we'll keep it, let's pass the image to. Self-recording, we're going to say image save to disk image. All right. So we'll keep that. Windows S saves it. Good. I think that works now. Process image doesn't exist. Let's go create a new one, and we're going to call this, we'll call it image processing.py. And we're going to, that's fine right now. We'll say there's a method here called process image, which takes an image. Can you see this okay? Yep. Takes an image. For now, we're going to pass on that. We'll go import this. And we'll say here, from image processing import all. All right. And let's just do this. Process image, that looks good. Main, for now, let's just, let's print the image and see what that looks like. We'll run Python main again. So now we should see this window, but we should see a lot of stuff here. So we have image, we have frame, timestamp. Okay. Jawwork, did you do anything fun today? What did your Friday have? So image frame. Let's go see what this image is. I'll keep that open. We're going to say Carla image. Oh, that makes sense. Images of a lady named Carla. Hey, good morning, Sound Blaster. Or Sound Blaster, Sound Master. Did anyone ever have a Sound Blaster card? Remember those? The sound cards from the old days? But hey, Sound Master AJ, welcome. Good morning. Thanks for joining. I remember Sound Blaster, and I remember fighting those cards a lot. I remember in the old days, if you're as old as me, the cards, the sound cards, a lot of the cards had these Sound Blasters. Yeah, totally 32-bit. Remember the IRQ settings? So there's these little plastic caps that you can move to different pins to change the IRQ. So you go into Windows, set the IRQ to 7, and go to the card and like have to move the pins to 7 to get it to work. Just the good old days right there. Let's see. So we're on IRQ not less than or equal error. Yes. Those are beatings. All right. I'm looking for image now. How do I do? Let's see. Control F works here. Yeah. Carla image. Let's see what we get here. We get FOV, height, image. Okay, raw data is what we want. Let's go back to No Machine. So I don't know if you, Soundmaster, I don't know if you joined a little bit late, but we've got Carla running 60 FPS now using No Machine. So I'm No Machining into the box, which I just found out about No Machine last week. Really liking it. So raw data. Let's see what this is. All right, so it's memory, so it's a byte array. But anyway, yeah, look, 60, 62. We're happy with that. Jawwork says, we've got the builders in. It's been raining. We've got the builders in. It's been raining in the UK for about 3 weeks. Lots of floods. Yuck. I do not like to hear that. So what are the builders doing? Are they, are you building a house, or are they like prepping where you live for rain, or fixing damage from the rain? All right, so now what we're going to do is go to GluonCV. Let's look at MXNet, GluonCV, and we're going to say image. We're going to say object detection. Yes, Soundmaster's saying builders equal construction guy. That's my question too. All right. Predict with pre-trained SSDs, predict with pre-trained faster RNNs. Let's look at the model zoo. So the model zoo here will tell us what type of model we want to use. So we have, what's the MAP on the Y and samples per second on the X. So samples per second is pretty important. Let's say we're getting 60 frames a second, so we want something in this area. And I guess the closest one over here is, I want to tell me what that is. Oh, ResNet V1. Faster R, ResNet 101, Coco. We can really just pick one of these. I think what we'll do is pick a small one to start with, and we'll go up from there. So we'll go to object detection. JAWSworks has a very small extension, especially compared to the US. There are no small projects, are there? Everything, especially with the rain, everything gets totally thrown off schedule. All right, so I want to go. I don't care about Model 2 right now. I want tutorials. Let's just get cracking on this. Pre-trained models built on ImageNet. So, do you know about ImageNet? There was an ImageNet contest to see like what algorithms or what networks could classify the most pictures or the most accurate pictures. I should say accurately classify pictures. But ImageNet, a lot of these are trained on ImageNet. There are specific training sets too for, there are probably some good that are good for self-driving cars that I don't know about yet. There are good ones for general scenes like animals and pens, paper, cups, things like that. Hey, Ice Cream, welcome. Ice Cream says, I try to tell my CEO there's no such thing as a small project. I know. All right, we're going to try. So this one does airplane, autos, birds, cats, deer, dog. Not a lot there, but is it just 10? 1, 2, 3, 4, 5, 6. So it's the Sci-Fi 10 set. But it will do automobiles. I think for now it's okay. We can just, I want to make sure this will be a proof of concept, and then we can always bump it up to a bigger set later. So let's bring this in. We're gonna go with that. So in process image, we're going to add this MXNet code here. So PyPlot will give us a library to show our images. MXNet and GluonCV, this is the neural network in the library that we'll use to access the network. Model Zoo will bring in the right model. So let's go get the model. The model is going to be, we download and show an example image. All right, let's do this. Hey, startup, welcome. Let's see. In India, what is it? 1733 or 43? Maybe 1843. No, it's further, isn't it? You're 6 hours past UK. All right, 6.5 probably. So the URL, let's see. So the URL is this. Let's look at cd out. This is where it was saving images. So we're going to pick one of these at random. We're going to say our URL is, oh, it's downloading that? I don't need to download. We're just going to say image file name is, image f name is going to be out 0441920.tiff. I haven't seen TIFF files in a while either. We're going to read it. We're going to show it as numpy. Okay, so it's bringing it in as numpy. We're going to block this just for a second. Actually, we need to do this. We need to bring this down here. All right. So we should see an image here, I think. I'm sure I'm going to do something wrong. Well, let's find out. Okay, so there's that, which we know about. That's the image has no object in read. Oh, okay, here's the problem. Image has to be, this is image here. Let's try this. Let's just get this working first. If name equals main, we're going to process image, and we're going to say process this guy right here. Oof. Let's just see if we can run this. Python. This is only my second cup of coffee, and I'm not typing very well, am I? Cannot do this. What's wrong with it? Oh, Python image processing. String object has no, I see. So we're going to read the image. We're going to show it. It should work. string object has no, okay. Let's think about this. We have to load this image, so it's coming in as a TIFF. We need to load it. I don't know why ImRead won't do that. Let's go back to this. So we're downloading an image here. It's a JPEG. It gets the file name. Yeah, I don't understand that. Let's just see what this... I don't want Twitch Studio. All right. Startup says it's 9:45 p.m. here. Bangalore, okay. Comfortable time to attend the Twitch in our compared to midnight. I bet it is. I do like doing them a little early too, just to kind of help the other people out that aren't in the States. All right, so I just want to see. So we're getting a file name here. We need to actually read this. We're getting the right file name, I think, but it could be that that file name is throwing it off. All right, so we're getting the right file name. Let's see if this works better. Let's print this image. Print image, and we'll exit just to make sure that everything looks good before going on. So string has no attribute. I think we have to load it in a different way. So let's do, I know we can do cv2 let's do image equals, I don't have OpenCV here, so let's do import cv2. cv2.imread. Will this work? Let's try this. String. Oh, I see what I'm doing wrong. So okay. That's a dumb mistake. So what I'm importing image from MXNet, and it's thinking, all right, we got this now. We just need to call this image. And we'll get rid of CV2. Told you it was too early. Too early for coding. All right. That should be better. Let's just see what we get here. Oh, man. I've been on a Mac keyboard all week, and now I get to Windows. All right, there's an ND array, which is perfect. That's what we want to see. Now we should see an image. And we should see, I don't know what we'll see, but we'll see an image from Carla. There it is. All right, so let's annotate that image so we can see a nice image there. Let's break out. Here we go. And let's get back to this code. So we're in the same point they were. Transforms. Okay, so typically when you run an image through a convolutional neural network, you have to do some transforms, and that means it can mean a lot of things. So some networks want their images sized differently, like 24 by 24, or they want the long side being 512 pixels versus whatever the original size was, so you have to resize it. So MXNet, one thing I found about it that I like is it does, I would have to go through and do all these transforms myself. So that might mean removing channels like RGB and just making it a grayscale image, doing the resizes, doing some rotations, things like that. But this comes with a really nice transform function. And so each network wants some different transforms. This network here, which is, again, the CIFAR 10, wants this particular set of transforms. So we're going to do that. We're just going to copy this code and try that. We're going to try to paste it. We're going to try to copy it right first. We're going to go Control-C here, and then Windows-V here. We're going to tab over to get that nice and straight. All right, so transform function, compose, so it's transforms resize. Okay, so it's making an ordered step of transforms. This right here, let's normalize. This is a famous or a well-known, what's the word? It's not an enhancement, but it's basically taking the means of the pixel values. It's doing some adjustments to the pixel values. So the first time I learned it, I was like, where did they get these numbers? Well, it turns out these numbers come from trial and error. But it's really, really frustrating when you're first trying to learn this and you're wondering, you're seeing code like this and you're thinking, why is this here? This doesn't make any sense to me. And that's what it was. The rest makes sense. We're resizing it to, I guess it's going to be 32 by 32. We're cropping from the center to make sure that we get the right pieces. So we have a transform function, and now we need to make sure that we run the image through the function. Lord of Sound, hey, oh, it is visible. Thank you. Boom. Thank you, Lord of Sound. At least we didn't stay on mute today. It's always a win, but lower thirds, that's my other Achilles heel. I have two Achilles heels, like most people. One of them is surgically repaired, by the way. All right, so now we're going to run the image through the functions, and then we're going to show the image. It's going to be ugly like this, but that's okay because it should be a 32 by 32 image. So we're going to run this through here, and we won't need this step during the when we're actually taking Carla's pictures live, but we do need it. We'll just use it now to make sure that we're able to see everything going on. So let's look at a 32 by 32 version of what Carla sees. That's definitely not it. I wonder if it, let's see. Image equals transform function image, plot show image. Let's do image 2 here just to see what happens. I really think we should see a smaller 32 by 32 image. Huh, we're not. Let's go figure out why real quick. What does a transform image look like? Definitely doesn't look like this. Okay, here's explaining 32 by 32 num channels. So it's doing an CHW, so channels height and width normalization, then mean and standard deviation across all the images. Okay, but I don't understand. This transform doesn't seem to be working. ND transpose image 120. All right, that's okay for now. Let's see if this still works. So we're going to grab the network. So this is a pre-trained network. We don't need to show this image, but we do need the transformed image. So here is, whoops, I didn't copy this correctly. All right, transformed image is there. So get the model, ResNet, classes are 10, pre-trained is true, that's good. Then we're going to run it through the network. I gotta quit jumping back to that one. Here we go. Predict is net. Okay. No, it's just going to classify the picture. That's okay. Let's see what happens. All right, so we're going to predict here the class name. So we should see 0, 1. So we should see class index of 1, an automobile. But we'll find out in just a second. Let's try this. I want to see bounding boxes, though, so we're going to have to find a different demo. Here, we don't want this. This is part of the problem. Let's try it again. We shouldn't see an image pop up. An automobile, good. We got that with a probability of 999. So that's good. So we know the classification is working. Now I want to see bounding boxes. So let's do, I wonder if dive deep will show us. Let's do gluon, MXNet, classification, no, object detection, bounding boxes. That's kind of what we want to see. Let's see, prepare, object detection. Pikachu. SSD. Okay, let's see what this has. No, I don't want that one. I guess we can start with this top one. Object detection. Let me go back to these other models real quick. I think some of the other models will have better libraries for us. Yeah, let's do this one. So we have the same, probably model, zoo, data, and utils. Let's make sure we have those three. I don't think our builders have been doing much. Use quotes around builders. We have data. I don't see data. Gluon, data, utils. Model zoo. All right, is that from GluonCV? Here it goes. Data. All right, we have that now. Let's go back to this. So here's our network this time. This time we're going to use SSD 512, ResNet 50. So 50 things, 50 objects that it can detect. So all we need to do, the transform may change, but let's go ahead and bring this model in instead. Model zoo, get model. All right. And let's see if they do any transforms that we need to do. Pre-process the image. So there's the image. Data transform presets SSD. See, this one's a lot shorter, a lot less work. So let's take that one. And again, this used to be a huge headache to do back in just a couple of years ago, really. Unless this existed a couple of years ago and I didn't know about it. So we're taking the image, I'm going to copy this here, resizing it, and it's giving us an X and an image. The X will be the input that we'll send to the network, so prediction will be network X, most likely. The image itself is probably a NumPy representation of the image. So let's just check it real quick. Print image, and let's exit, just to see what we're working with. Could not open, let's see, imread, could not open file. Image is this. Let's see what X is. How long was the project supposed to take, Jawwork? And this, so I guess the rain does definitely put a hamper on that. All right. So let's see what the problem is here. We're getting the image. We're getting a file name. Check failed. File open. Line 15 of process image. All right, let's go look at line 15. Line 15. Okay, we're doing that part. I'm wondering if the problem is here. No, it shouldn't be here. This should be good. So that was fine before. Let's just let's back out a little bit and see what if we did anything different on the last model. We just transformed it. That's all. And we're doing the same thing here. Oh, X image. This is probably it right here. Let's print image now. We should see no errors. We should see a NumPy array, which would be the shape, the pixels, and the channels. We're still not seeing it. Load test. We're definitely getting some of it. Another month, but 2 weeks wait for glass doors. 2 weeks wait for glass doors. That's not cool at all. All right, I'm gonna focus on this. Let's see what the deal is. Image file name is utils.download. So they're doing the same thing we're doing. Oh, they're just taking the file name though. I think that's all I'm taking. If we look here, this should just be a file name. Oh, we're doing an imread. We don't want to do an imread. So this transform happens to take just the file name of the image, which is interesting. So we're gonna go with that and just see if this looks better. Print. That's one thing I do like the transforms. I wish they were more uniform. So one takes a file name, one takes the byte data. So I guess you have to pay attention. There we go. This is what you want to see. So these are just the pixel values of the entire image. So, or of each channel. So RGB of the image. Actually, maybe BGR with OpenCV, but all right. So we have that, and then the X will be what we're gonna pass to our. We're getting that there. Prediction equals net X, and we don't need class names or index or that just yet because there was some more sample code here we want to look at. So class IDs, scores, bounding boxes. That's what we want. We want the bounding boxes, which will give us 4 coordinates for drawing boxes. And then the cool thing too, that used to be really not hard. I think we've done it on a stream before. We used it with recognition. Recognition returns bounding boxes, and we had to draw out the boxes ourselves. MXNet will take care of that for us, which I really love about it too. The Tektron did this too, if you remember last week, but Control C. I'm really going to have to bring a Mac keyboard up here for the next screencast. All right, so class ID scores bounding boxes equals net X, so we don't need to do this yet. AX, what does that stand for? AX, I have no idea. Let's run it and see what happens. Model zoo is not defined. I did think we had that. GluonCV, oh, so we're getting it right there. That's okay. Let's Let's bring it right there. Run this again. Okay, so we get a car, 100% probability, which is good. And we get a bounding box, which is really good. I don't know what this is. This is a warning. I'm not sure what that's saying, though. That's okay. I'm not worried about that just yet. So this is good. So now what we want to do is take Carla's live feed and run it through the same process. And then we can see in real time, we'll see this value. So we have 30 minutes. We're going to make that happen. This is the point we needed to get to, though. All right. So process image. So one of the things that, so let's do one thing real quick. Import time. Let's see how long it takes to do the inference. Import time. It's not going to be in real time, but it'll be close. Net is that. So we want to load the net outside of this image processing. That way we load that one time. We process the image, so we get this. It's got to transform it. We need those values. We're not going to need, we might need plot. Where is, okay, netx. This is where it does the inference. We're going to say t0 equals time.time. And it's going to do the prediction. We're going to say print took time.time minus t0 seconds. Let's see how long this takes. Curious. Time takes no arguments when given. Time.time. Oh, I don't know what I was thinking there. So, construction. My brother-in-law was building a house, and he was just waiting on concrete. So 0.02 seconds. We can live with that. He was waiting on concrete, and it was really rainy here in Texas it's been rainy for a long time, actually. And it took at least a month. It delayed the whole project at least a month. All right. So we're good there. 0.02 seconds is good. Plot show. This is where we're going to have to get a little bit creative. So let's think about this. So we want to process the image, and we want to show it each time. So we're going to use, what is it? CV2 has a feature we can use. CV2 dot, can we just do this? CV2 imshow. So AX is the utils, so it's plotting that. I want to show that every time. Process image. Process image. So over here in main, this is on a loop, self-recording. This is active, so this is true. Instead of saving a disk, we're going to process the image. So each frame will come to this. Process image, image. Each frame will get predicted, and each frame will draw a box. But I think this is going to draw a lot of boxes. We just want the result. So what is just the result of? Let's see, utils viz. Let's see what utils does. How do I find that? That's gluon. Where's utils? GluonCV utils. I think we need just the image. We don't need it to pop up because we want to use something else to do that. GluonCV image utils. All right, plot image, which is what we're doing, right? Or plot bounding box. I do need that. So plot B box, visualize image, visualize. I'm not sure about that one. Expand mask. Ooh, segmentation mask. Will that work too? Plot mask. Let's try that real quick. That'd be cool. So plot mask. Save this. Plot mask got an unexpected keyword class names. Oh, because we don't need that, so let's take that out. Okay, it's got some different, it's expecting some different parameters. So image masks and alpha, binary mask, alpha. I like that, but it's going to get me sidetracked, so we're not going to mess with that just yet. Although it'd be really cool. Maybe we do, we'll do boxes first. So let's just undo this. Control Z. All right. Go back to this. So plot image. I really wish, oh, map plot lib axes. That's what AX means. wonder if there's actually a demo here where it does it with the video. Let's try it. Object detection video. MXNet Gluon object detection video. On a webcam. Alright, this will help us get there. So CV2 we know we want to use. Net hybridize. Compile the model for faster speed. Well, yes, please. Why would we not want that? Why isn't that in all the demos? Create the webcam handler in OpenCV. Detection loop. Okay, axes is none. Lord of Sound. Hey, Trinity, welcome. Num frames 200. We can change. I don't know what that is yet. For iron range, that. So it's getting. It's reading from the camera. Processing. Frame equals that. Run through the network. We know how to do this. Oh, here we go. Can we just do that? Class ID scores bounding boxes. Oh, here it is. Image equals CV. This is what I want, I think. Image equals GCV utils CV plot bbox. Oh, CV plot bbox is different than this. Oh. Here's what we're going to do. Alright, we don't need that there. We need this here. So image is GCV, which we're bringing that in already. So utils viz. So the difference is CV plot box is going to give us the image without doing the visualization, which is what I wanted. CV plot image wait key. Okay, let's try that. Wait key 1, so it's going to wait for 1 millisecond. I don't need that. Okay. I actually think this might work without a lot more thrashing. Let's try it. Is it naive? Oh my goodness, this keyboard. You can expect a different keyboard from me next week. Alright. Let's make sure this is going to work. What is frame? Oh, frame we're not getting. Frame is MX India array. Cap read. So it's getting a NumPy. Most likely. Data transforms. So it's on the transforms. Our transforms happen here, so it's image. So this is going to be image right here. And I think everything else looks good. So we'll run this through the simple one frame test first. Okay, that was right. It does it for one. If we did it for 0, that would make it where it didn't go off the screen. So this should just give us one screen with a bounding box. It's perfect. Well, it's weird that it changed to 99% instead of 100. Why would it do that? Anyone know? Same network, same image. Maybe this algorithm for some reason. I don't know. Oh no, now we're going to be stuck, aren't we? Control Z. What's going on here? Let's see. Kill. I know you can't see that. I can't either, so I'm typing blind. Kill -9 16799. Okay. So what we need to do here, we're going to say process image. All right, we're going to do this. While true, so we're going to start a loop. And we're going to say process image that if CV2 wait key 0 equals Q. So if we hit Q, then we want to break. We want to get out of the loop. So when I hit Q, it should get out of the loop for us. CV2 wait key 0 equals Q. I think that works. Trinity, let's see, what does ice cream say? Having a great week, thanks. Awesome, glad the work week is almost over. Hybridize has enough. Oh, you're right, Joel work. So it made it faster, but it made it a little less accurate. Let's check out hybridize and just see what happens. Q's not working. Oh boy. PS, kill -9. I'm gonna have to look that up, the wait key part. Kill -9 17579. Oh no. There we go. Let's get rid of hybridize and see if we get back to that's a good catch. All right, let's look at this wait key thing. I'm trying to do that from the old days. So CV2 wait key CV2 wait key 0. Google's not going to like that. Python CV2 wait key 0 break. And I think there's a destroy windows or something. Destroy method. CV2 destroy window. All right, CV2. So we're doing while true. That's good. We're doing that. Try, accept, destroy window. I think there's just, yeah, destroy all windows. I like the way they do this though, the try and accept. So let's copy some of that code. Ooh, tiny screen. Just for a few minutes. All right, so we're gonna say while true, process the image. Then we're gonna say try CV2 wait key 1. Whoa, my no machine just died. Interesting. Hybridize. QQ. Are you asking for a quick question, Trinity? Hit me with your QQ. By the way, I think a lot of you probably have a lot of points built up. The channel points, I have 5.6K. We need some special, we need some icons or something, right? It died again. What's going on? No machine. We're about to have a fight with no machine. It's been so good to me. There's a setting, there's a resolution setting, so if this doesn't work, I'm going to assume there's some kind of conflict, and I can change that and see if that gets us in. Oh, you're QQing which in MMOs is how you cry. I didn't know that. I didn't really play MMOs. You guys are more cultured and sophisticated than me. I don't like this resolution. How do I make it? That's too big. Hold on. There's a way up here. No idea what I can do. Special. Oh, look, Amazon Alexa. Special emotes are in the artist backlog. Low priority. We have points to spend. Amazon Alexa. Oh, when I was hitting QQQ to kill the window. Okay, it all comes back. What is going on here? Why am I all over the place? Close that. I guess we're gonna go with the big window. That's fine. It looks good. All right. This part is kind of annoying, but here's what we're gonna do. We're just gonna let it run. We're gonna take out. Because I don't want to spend all our time figuring out that part. I want to see a beautiful bounding box on an animated. All right, we don't need this anymore. On an animated dash cam. All right, so we've got that. We're taking out hybridize. Actually, we're going to put it in. I can live with a 1 point reduction in accuracy. We're going to take hybridize back in. We're going to run. We're going to go to terminal, and we're going to run conda activate Carla. And then we're going to run Python main.py. Here we go. I want to see bounding box. Amazon Alexa, I want the new emotes too. Some people think big global events are more important. Yeah. You know what though, with coronavirus, those big global events may not be happening as often as we think. Did you see Facebook canceled theirs? All right, we're getting some problems here, but we're going to fix it. MXNet, invalid parameter for layout. It's looking for batch number, channel height width. Wow, I don't know where it's dying here. Why didn't it die before? So we're getting the image. Oh, I know what's happening. So in main py, we're sending the image, but it's raw data. Whereas before we were looking for a file name. So I think we can do. We could just pass %08D image frame number. We could just pass this. I mean, there's a couple ways we can do it. We can get the raw data from the image, which we're getting anyway. So let's do that. Process image. Let's go to image processing. Right here, we're going to change this. We're going to say image equals image.raw data. I think this is what we want. Let's try again. Trinity, true. Many companies pulled out of GDC. Yeah. There's some AWS summits coming up. There's all sorts of like big Amazon conferences in the next 4 months or so. I do wonder how that's going to play out. I know we have a summit meeting next week. So we have our Japanese team, I think they're out, Amazon Alexa, is that right? Maybe a few others. Which is sad. All right. Let's see what's going on here. Print image. Let's see if we're getting raw data. It should be byte data. This is a problem. Process image. Main PY, processing import this. Oh, right here, this file's having problems. What's going on with this file? Python image processing.py. String has no attribute raw data. Yeah. Okay, here's what's, I think. Let's comment that out. Let's run main again. Ice Cream says, I supposedly need to shave my beard now too. Does the beard, I guess it does. Beard attracts, or traps bacteria and stuff, right? Who's telling you to shave your beard, Ice Cream? Is work telling you, or are you just thinking? Is the news telling you? Don't listen to the news. Don't read it. Don't watch it. It's not worth it. It's not CDC approved face mark. Oh, that's true. Yeah, if you want to wear a mask, you can't have it. It's like when you scuba dive. Like I've had to wear, like long story, but you have to shave a lot of times for some of those events. Yep. I did not see the chart. The CDC chart, apparently, for approved face masks. It makes sense. All right. Image processing line 13. Something bad is happening here. So, I wonder why that's failing when we call it from main, it's failing, but when we run it normally, it's not failing. The error is invalid parameter. Expect int or none value is that in this convolution. We're not even passing it a... Okay, let's just try this. If I have a process image with an image, and we just say pass, do things work? We'll change this to process image 2. Does main work for us? Doesn't work. I'm so confused. We're going to comment out everything. This should work. If it doesn't, then we're just going to quit working for the whole day. We're done with everything. All right, we're working there. Trinity, I don't know if you got here or saw this in time, but we are closer now with no machine to 60 FPS. I am running the server and the client on the same machine. I bet if I run the client on a different machine, it'll be even better. But all right, so that works. So there is something weird in this file going on that we need to fix. Control C. I like this little message. Hello from the Pygame community. Thank you, Pygame community, for all your work. It's a lot of fun. All right, so we have process image. I think what happens is this net. I wonder if Hybridize was messing it up. Maybe that's why it's not in all the demos. Nope, the net is what's messing it up. So net is models you get model. So models you comes here. Oh, we're getting two models. No, we're getting that. And we're getting get model. We don't need this anymore. We're getting get model from this. So let's comment this out. Get model. We're getting the SSD 512, ResNet 50, pre-trained tree. That's all normal things. There's nothing funny happening there. But we're gonna have to do a Google search. So ResNet 50. Oops, Control Shift C. You just ran a red light. Let's check these masks out real quick. Facial hair styles and filtering face piece respirators. Not a lot of green check marks. Oh, the Fu Manchu is good. You can just go Fu Manchu. I should have seen your beard before. I would put you at Bandholtz. Is that correct? Are you still Bandholtz? Bandholtz. Are these... Oh, these are beard styles, huh? The chart is awesome. It is. So, Amazon Alexa, we need these as our emotes. We need CDC approved beard styles as our emotes that we can buy with our Twitch bucks. Nope, it has an X. Yep, Bandholtz. Yep. I like that. All right, here we go. Let's see if anyone can fix this for us. We only have 9 minutes to solve this. Error message, blah, blah. I don't know if you're like me, but on GitHub issues or these, I just scroll and look for a lot of thumbs up. Only one thumbs up there. I need one with like thumbs up and the little fireworks emoji. Onyx changed the blah, blah, blah. PyTorch, okay, it's not helping me at all. Looking for thumbs ups, nothing. It really doesn't make sense why this would happen right here. So I'm going to get rid of it. And we're going to get rid of this. We're going to come back here and uncomment this. Oops. All right. Let's just see if we can get the raw data without any kind of other. It should just give us raw data and fail. Process image is not defined. It is defined. Process image. Whoops. All right. Really would like to change this resolution again. All right, so did that. Some threading issues. And okay, so that memory, that's just the raw data. So we need to load this raw data, which we can do. I think load test. Let's go back to this sample code. I want to keep that one open. We need this one, but there was the one we were at earlier is the one we really need. Gluon, object detection, tutorials. Nope, let's go forward one. That's Sci-Far. We know we did good with that one. I guess we really could go back and just do this with Sci-Far. That won't be too hard to change. So let's just go net get model Sci-Far, the Xavier. So remember those that weird array of 4 digits, the mean and the standard deviation? That's Xavier. Okay, we're going to do this just in the interest of time. All right, here's our network. We're going to load it outside of this. We're not going to hybridize it. X image data transforms blah blah blah. Image is right there. Class IDs. Okay, let's go get the rest of this data. Transform compose. We need this. So in here, the transforms are going to be a little different. Paste that. There's our transforms. It's quite a bit different. All right. What do we have here? Ice cream can't clean shave and have a cooler name. The Lex Luthor or something. Yes, that'd be great.
I don't know that one.
How did she? Oh, she heard her name. Guys, I'm sorry. I don't like this either. We're gonna go back. We're not gonna do Sci-Far because I don't think it's gonna print the bounding boxes right for me. We just need to load this data better. So image equals, let's try cv2.mread. How do I load bytes in cv2? We're getting a byte array. We just need to load it from a byte string. FD read from string cv2 np from string image string up. Okay, let's try that. Paste it. np2 from string image. And let's just see if this looks like a nice little numpy array. Print image exit. Do I have numpy loaded? Nope. Let's see what we get here. Oh, Alexa wakes to Lex Luthor. Creepy. Alexa, are you Lex Luthor?
Here's something I found on the web. According to liveabout.com,
Alexa,
Lex Luthor.
Ask Sam Jackson who Lex Luthor is. The error we're getting was it needs a
Alexander Joseph Lex Luthor is a fictional supervillain appearing in publications by the publisher DC Comics. The character was created by Jerry Siegel and Joe Shuster. Lex Luthor originally appeared in Action Comics number 23.1. He has since endured as an archenemy of Superman.
An archenemy of Superman. Alright, well, I have some problems here that are going to take too long for me to fix on the stream. So the issue, we know we're getting bounding boxes, that's good. The issue is we don't want them to print on the screen yet. We want to be able to show them frame by frame. We're having trouble, I'm having trouble, loading the image coming from main.py, which is here. Oh, here's what we'll do. We can get around this, I think. We'll do image frame number, which is like the that plus TIFF. We know they're saving as TIFF files. We also know that this should be out slash that plus that. So there's the image frame number plus TIFF. That's fine. I'm mixing my quotes. Doesn't matter in Python, but I do like to keep it uniform. It bugs me when I have singles and then doubles in other places, but not something we have to worry about here. All right, process image. So we're going to get the file name this time, which we're going to say is better for us. So it's going to load test. Let's see if it can load. Let's see. Image equals cv2.mread image. That'll get it in cv2 format. That should get us here. That should get us here. Let's see if that works. There's our car, but we are getting, okay. We just need to change one thing here. We need to make this a string because it's a frame number, and it didn't like concatenating with strings. Let's see. What about the CGI mustache? Was that on there too? CGI. Balboa, is that like Balboa? There's pencil. Where am I missing CGI? Is it not a type? I do like those. Alright. The error we're getting is image read for F and file names. Let's go back to image processing. Print image. Let's just do it this way. Python main right here. And we're going to do that. Process image that. Let's get back to where we were. We were close. Image processing.py. We can see the errors better this way. So it's a normal image. I don't understand what's wrong. So that's good. SSD load test. I don't think I even need to do that. But we do need to get this X value out of it. Data transfer presets SSD load test. Let's look that up real quick. MXNet SSD load test. In response to Superman being clean shaven. Oh, I remember that. Yeah. That was a terrible mustache. What was his name? I didn't watch. I couldn't do those. For me, it's got to be Christopher Reeves or nobody. Load test. I did forget. That was a very terrible. That's kind of like. I didn't watch Cats either, but all the CGI issues with Cats. Like, why did they even let it get out like that? Load test. They had to render skin over his beard. Oh, I didn't know that either. I thought it was a CGI. So they rendered skin over it. Why couldn't he? He must have been shooting 2 movies, huh? Load test. To load all images, transfer them to a tensors. Let's see what it expects here. File names. Okay, well, we're sending it a file name. The error we're getting is... Save it. Image processing.py. Okay, let's see. All sorts of fun errors. Could not open file or directory. So just having trouble finding this. Oh, it could be cd out. Let's just give it a different one. 05079916. All right, well. Not open. Here we go. I know what the problem is. It's looking for a file name. We're converting it right here. We shouldn't be. Net is not defined. Now we're getting somewhere. All right. That's all right. Process image. We just need to do, so it's plotting the image. Let's just do CV plot box. If we do this, take out the CV. This should give us the image itself again. Party Paul, what's happening, Paul Cutsinger? So this is where the cool kids are. Paul is an early bird, so yeah, if we want Paul on our stream more, which we do, we need to get him. We need to do these streams way earlier. Has no attribute shape. Shape. So let's do one thing real quick. Let's just show Paul where we are before we end this stream. We do the transforms. Oh, we did this. Let's do this compose part. I think we've forgotten this. All right. So we do our that. Oh no, we aren't going with this route anymore. We want this nice one right here. All right, load the model. Detection loop, here we go. Read frame. CV2 convert color. Class ID scores. Let's do this. And bounding boxes. I think we're getting that here, but let's make sure. Yeah, we get the bounding boxes. CV plot viz. CV plot box, okay. This is what we want. We're going to change this to weight key 2, and that'll let us see the image. Let's make sure. Control C, window V. All right, I think this will work. Whoops, we're going to change this to 0. Where's GCV? Oh, we don't need GCV, we just need this. And we're going to do this. Hi, Paul Cutsinger here. Nice to see you. Do we need Twitch sessions anymore? Yeah, Paul, we need Twitch sessions. Okay, so look at this. Who pointed this out? Jawwork. Yeah, hybridize. We're back to 99% without hybridize, which is so weird. That was 100% at one point. That 1% could mean a difference between making Trinity happy by us hitting other cars or keeping us safe by not hitting other cars. Trinity loves damage. All right, I think we're at an okay stopping point. So what I'm going to do is, back in main, what will happen in this loop? The loop for process image. Let's go back to that. Process. This loop right here is going to send a file name this time, which is way easier for us to work with, apparently. To process image. The process image will loop through it. So we will be driving, and this green box will follow our cars. It will also pick up these other ones that are out here in the distance and every other one we come across. The problem with this, this Resident 50, there are only 50 classes. So if we looked at the classes, I know we'd see automobile, obviously, but there's not a ton. But I would bet we don't see traffic light. I don't know if we see building. Here, I know what we can do real quick to show. Control C, break out of this. Control Z. PS, kill -9 20244. All right, if we just do netx print net.classes sys.exit. Let's just look at the classes we get here. But we'll want to change this model eventually too, is the point, because 50 objects is not enough. But it will give us a... All right, so it gives us aeroplane, which I love. Bicycle, bird, boat, bottle, bus, car, cat. Did it call it auto? Didn't it call it auto, not car? Who knows? Cat, chair, cow, dining table, dog, horse. That's a very... motorbike and person. That's a very eclectic mix of things that it notices. But we'll get a bigger model, but I think I'm going to get it working with this one first. And then we'll switch the model out and see what the time difference was. So if you remember, it was 0.02 seconds for it to identify a car. We'll see if it changes as we use bigger models. Let's see. Did you see the chart face? Oh, I missed some stuff here. Trinity, I think 1% will allow us to hit pedestrians. Paul says, I've moved over to the engineering team, so I've been kind of heads down. I miss y'all, though. Definitely want to get back on the stream. Good. We missed you, too, Paul. Soundmaster, Trinity. Got to watch out for the aeroplanes. I think I'm going to finish. I'm not going to listen to it on the stream, but I'm going to go listen to the Red Hot Chili Peppers song that mentions aeroplanes. Let's see. TV monitor, but no building. Yeah, why would it recognize a TV monitor? All right, well, I'm going to keep working on this, but I'm going to have to drop. It's great seeing you. I'm going to be out next week and the week after, so we'll have 2 weeks without Voice and Robotics. But I hope you still have great weeks, as I'm sure you will. And if you need anything from us, the Alexa team, don't forget to check out. Let's go look at the Amazon Alexa calendar. We've got Alexa Game Chat Monday, March 2nd at 1 p.m. Pacific. Skill reviews are really fun. I sat in one of those last week. March 3rd is a skill review. Then, of course, office hours. Anything new and fun? Alexa and Friends? I'm not sure about that one. Amazon Alexa.
I don't know that one.
Alexa, do you have any friends?
Lots of people talk to me.
Yeah.
I try to be friendly with all of them.
3 new streams next week, all at 7 a.m. Pacific. Ooh, that's nice and early. Well, good. I'll tune in for some of those too. In fact, we'll be in Seattle, most of the team, so I think you'll see a lot of us on camera, which is great. All right, well, thanks for joining. Appreciate it, as always, and have a great weekend.